So in this video, we're going to talk about dividing polynomials. So you have in the past added, subtracted, and multiplied polynomials, but we have never actually done division before because it's a little more complicated. And so that's what we're going to get into today. Basically what happens with dividing polynomials is it works very similar to the way numbers are divided with long division. That's one of the ways to do it. And so before we get started, I wanted to show you a quick refresher on how long division works with numbers so that we can do it with algebra here in a second. If I want to know 365 divided by 10, also written as 365 divided by 10. Just a little refresher, this is called the divisor because you're dividing by it. That's the dividend. The answer is called the quotient. So I know you could easily do this by just moving the decimal place, but I want to show you long division. It's probably been a while since you did this. You got to draw like this little box looking thing, and then which of these numbers goes in the box? Do you remember? It's always the first one or the top one. I like to think of that one as the most important because it comes first. So the dividend goes in the box. Then the divisor goes on the outside, and the answer will be up here, the quotient. What I'm going to do is see how many times does 10 go into 3. It doesn't, so we'll try another one. How many times does 10 go into 36? It goes in 3 times, evenly. So we'll write it right above the 6 since we did 36. Then 3 times 10 is 30. What I'm going to do, if you remember, is subtract that amount and see what's left over. So 3 minus 3 is 0, 6 minus 0 is 6. Then I'll bring down the next number and do it all again. 10 goes into 65 6 times. 6 times 10 is 60. I'm going to subtract, and I get 5 left over. At this point, I have nothing left to bring down. So I actually have 2 options. The option you probably learned in middle school was just keep going, but add like some decimal places. So we can do that. Let's bring down a 0. So 10 goes into 50 5 times. 5 times 10 is 50. And when you subtract 50, you get 0. And so now that I have a remainder of 0, I know that I'm finished. If I had a decimal here, I should have a decimal up here in my answer, and the answer is 36.5. There's another way to do this, though. Instead of doing that 0.5, when you get down to right here, when you get down to just the remainder, so like I was done, but I had a remainder of 5. What you can actually do with that remainder is just put it over the divisor because this hasn't been divided yet. What I have left is 5 divided by 10. I haven't done that yet. And then just tack that onto the end. So instead of a decimal, this is a way to write the remainder as a fraction. And notice it's the same thing that I got before, 5/10, same as 0.5. I could simplify that to 1/2 if I wanted to. So my answer is 36.5. Okay, keep that process in mind, the whole like, how many times will it go in, put that amount up here, multiply, subtract, and then do it all again. Bring down the next number. Okay, we're about to do it with polynomials, and it's going to work very similarly. This says to evaluate this, and so that just means to divide it. See what you get. So what I'm going to do is start with the term to the very left of my divisor. So how many times does x go into x cubed? Basically, how many times could I multiply x times x times x to get x cubed? Or like think about if I took x cubed and I divided it by x, what would be left? It would be x squared. Another way to think of that is if I take x squared times x, I would get x cubed. Just like over here, when I took 3 times 10, I would get the 30. So x squared times x gives me x cubed. X squared times 3 gives me 3x squared. And so we're going to do that as well. It's almost like you're working with two things at once here. Okay, so the reason I did that is because I'm going to take this and subtract, just like I did with my numbers. And when I do x cubed minus x cubed, it will be gone, and I'll have this other stuff to work with. Note that I'm not just subtracting x cubed, I'm also subtracting this term as well. So you kind of need to distribute that negative. And so this is going to become a negative x squared, a negative x cubed, but also a negative 3x squared. And you could change that to a plus at that point. So x cubed minus x cubed goes away. Negative 6x squared and negative 3x squared just makes negative 9x squared. All right, I know this feels crazy. Just hang with me. I promise that once you try some, it won't be as bad. Now that I've got this, I'm going to do what we did before and bring down the next thing, bring down the next term, which is plus x. And we are going to repeat that process all over again. So I'm going to come up to the top here and see how many times will x go into negative 9x squared. Basically, what could I put up here so that when I multiply it by x, I get negative 9x squared? Obviously, it's going to need a negative 9, but that's not enough because negative 9 times x is just negative 9x, and that's not quite enough. So I'm going to need an x term as well. So negative 9x times x gives me negative 9x squared, and it matches with this. Again, another way you could do that is take the negative 9x squared and divide it by this and see what you get, which would be the negative 9x, which is what we put here. Okay, not only do I need to multiply it by x, but I have to multiply it by the 3 as well. Negative 9x times 3 would be negative 27x. It's okay that these don't match up because we'll have just some leftover stuff. Okay, like we did before, don't forget that we're subtracting this stuff. Need to subtract it, which means basically make both of them negative, although they're already negative. So what happens is negative negative becomes plus. Sorry, I'm trying to make that stand out. And negative negative becomes plus. Okay. So that goes away, negative and positive. And then if I have 1x plus 27x, 27 plus 1 is 28x. Remember, that's just combining like terms. Don't try to combine the x's. If I have 27 of them plus 1, it gives me 28 of those x's. And we're going to do it again. So